All right, my dear students, you are welcome once again to our lesson for today. So we are still on the concept of the perimeter, area, and volume of shapes. Yeah, so previously we were able to go through the perimeter and the area of shapes. Yes, that's plane shapes. We're able to find the perimeter of a rectangle, triangle. We're also able to calculate some examples of area of a given plane shape. Okay, we also looked at some few examples of related application questions. Yes, so today we are going to continue from where we ended. In that case, we are looking at the volume of shapes. Yes, the volume of shapes. So we'll not waste time. That is what we are going to look at today. That is volume of what? 3D shapes. 3D shapes. Yes, that is what three-dimensional shapes. Okay. Yes, and that is going to center on what? Prisms. Yes, prisms. We know that when we talk of 3D shapes, we have different kinds of what? 3D shapes. We can even talk of the um, pyramid. Yes, that one is there. But for the purpose of our lesson for today, we are looking at only the volume of prisms. All right. Yes. So let's look at what when we say prism. What is that? So we are saying that a prism is a three-dimensional shape with two identical parallel bases connected by flat, that is the literal faces. We are also saying that prisms are named after the two-dimensional base shape. That is, the two bases are also what? Congruent polygons. That means they are the same shape and size. Yes, that is what prism. So if you look at the definition, we are just trying to say that to get a three-dimensional shape, we need to get it from what? A two-dimensional shape. We've already talked about two-dimensional what shapes. That is where we mentioned rectangle, triangle, trapezium, kite, rhombus, and all that. All those ones are what? Two-dimensional shapes. So today we are going to build um, three-dimensional shapes from two-dimensional shapes, and then we'll look at how we'll be able to find the volume and the total surface area of that given or three-dimensional shape. All right, yes, that is very, very interesting. But I have a very powerful tool that is going to help us. Yes, that is GeoGebra software. Okay, so we are going to look at how GeoGebra software will help us able to generate these three-dimensional prisms from two-dimensional shapes. The purpose of this lesson is not how to use the what do you call it? The GeoGebra to what? To draw shapes. That's not what we are doing. We are only looking at how to identify those uh, prisms, but um, the GeoGebra is going to be a tool that is going to help us. That's why we are going to use it. All right. So we'll not waste time. Let's quickly go to the GeoGebra and explore. Okay, how we are going to draw some shapes. All right. Good. Great. So this is our GeoGebra software. All right. Yes. But before we look at how we are going to uh, explore here, let me introduce myself once again. So my name is Evans. I'm still your mathematics facilitator. So I'm still going to be your instructor for today's lesson. All right. This channel is Maths TV. You can get Maths TV on YouTube, TikTok. You can also follow me on Facebook. But please don't forget to subscribe, like, and share the videos as well. All right, so if you look at this interface, that is GeoGebra software. As I said, that we are not learning how to use the GeoGebra to draw shapes. We are only what our lesson for today is just to find the volume of what prisms. Okay, but we have to identify some of the prisms that we know. And since we are going to get these, we are going to develop these prisms, these three-dimensional shapes from the two-dimensional shapes. This powerful tool, which is the um, GeoGebra, is going to help us. That's why we are using it. Not that we are learning how to use it, but as we are using it, you can take it as advantage and learn how to use GeoGebra software to draw shapes. All right, yeah, it's a very powerful tool which is recommendable. All right, so this is what we have now. You see this interface. Now when you take the Cartesian plane, you realize that we have two axes. We have both the y and the x axis. All right, yes, but in the that is used to draw two-dimensional shapes. You can use to draw rectangle, triangle, a square, kite, and all that. Okay, but if you want to get three-dimensional shape, then you need to get the three dimensional what axis, and that one we have x and y, and at the same time we have what the z axis. So let's look at how we are going to get that one. So I will come here and go to my view. Okay, then I will add what 3D graphics, 3D graphics, so that I'm going to combine the two. So this is what we have here. This means that I'm going to use both the two-dimensional um, plane and also use what the three-dimensional plane. So if you look at this, you see that this is the z. Okay, the blue color is the z axis, and then the red is also what the x axis, and the green is the y axis. Yes, so if you compare the two, you realize that there's a bit different. Okay, all right, so let me drag this here small so that we get a perfect shape, a nice one. Okay, yes, great. So first of all, we are going to draw a polygon, but you know that we can draw what a triangle, because a triangle is also a polygon. Okay, so if I'm going to draw a triangle, then I'll come here. Okay, so this time I'm going to choose a regular polygon. Now note that when you talk of prisms, we have a regular what prisms and we have irregular prisms. All right. When we talk of regular prisms, it means that realize that all the phases are what identical. Okay, every prism has what two phases, or the base. Okay, the base are what identical, and then they have other what identical phases. Apparently is what um rectangular phases. All right, so let me click here, okay, and then let me try and draw um so I'm drawing yes. So as soon as you try to draw, you see this pop up. Okay, we want three-sided shape, so I will clean here and enter three, then I will hit on OK. Okay, now you realize that as soon as I hit what OK, now a triangle has been drawn on the two-dimensional plane and at the same time on the three-dimensional what plane. Okay, so you look at the triangle, you see that this is what a two-dimensional shape. Now we are going to use the same thing to get what a three-dimensional shape. So let's see how we are going to do that. All right, great. Great. So let's see. So if I want to develop the 3D from this to get a prism that is a triangular prism, then what I will do is that I will first get what my height, because it is from the height that will help me get what the actual what prism. So I will come to this one. I want to get a slider. Okay, so I'll create a slider. The slider will help me get what a perfect prism. Okay, so once you click that, you hit on any space and then you get this. So the slider, because I want to get the height, so I will use h as my height. Then I'll come here for the minimum. I'll start from 0. As for maximum, I'll leave it like that. Then increment, I'll write I'll choose for 0.2. All right, yes, then I will hit OK. Then you realize that my slider has been what? yes, produced. Okay, so this is my slider. Now the slider is going to help me, but you realize that this shape is what is a two-dimensional shape. It is not a prism. So we have to get our prism because we've already drawn a two-dimensional shape. So we want to get a prism. So I will click the input box and then type what? Prism. Okay, so the moment you type prism, you see this one. Then you move on and choose what? The second one, which is what? Prism to bracket what? Polygon and then height value, because my slider is the height. So I'll choose that one. Okay, yes, and once I choose that one, then you see that this is my polygon. Okay, so I will type polygon because that is the polygon. Then you know that my height is h. Okay, so I will type my h there and then hit what? Enter. Okay, yes. So once I hit enter, then I can go on. All right, can go on, and then on my slider, I want to increase what? The height. So I will do this. So you see, now on the three-dimensional plane, you realize that it is moving. Okay, the height is moving. Very interesting. All right, now I've gotten my prism from the two-dimensional shape. Now let's go to the three-dimensional plane and rotate it so that we get the actual. So you see, yes, so that is our hot. Yes, that is our shape. Very nice. Okay, you can rotate it to any side you want. Okay, yes, so you see that now the face or the base. Okay, the base is what? Is a triangle. Okay, now let's look at the other phases. All right, so you see that for the other phases. Okay, now let's look at this face. So you see that now this face is what? It's a rectangle. Okay, it's a rectangle. Now let's move on and see another face. Okay, so you see this face as well. It's also what? A rectangle. So you realize that the base of the prism is what? Is a triangle, but the other faces form, that is what we call what? The literal face. It is what? A rectangle. A rectangle. Okay, so it is from the triangle that we got what? The rectangular what? Literal faces. All right, yes, so that is how it is. Okay, now if you want to clear these lines here, we can come here. Okay, and then we click here and click empty like this, then everything goes so that you have the actual shape there. Very nice, very interesting. So this is what our triangular what? Prism. So for triangular prism, the base is a triangle and the literal faces are what? Rectangles. And how many literal faces? You realize that we have three of the literal faces and we have two of the um, triangular faces, which are what? Parallel. Okay, yes, and they are what we say they are what? Identical. They are also what? Congruent. That is the base. All right, now let's try and see if we can get more shape from this one. Okay, all right, good. So I want to get more faces. Now I want to get four-sided figures. So a polygon, when we talk of four-sided figure, we can think of what? A square, um a rectangle, trapezium, and all that. So since we choose regular polygon, definitely all the sides are going to be equal. So if we get four-sided figure, then it automatically is going to be what? Square. Okay, so if I want to get four-sided, I will just come here where I I created the polygon. Yes, I'll click there, then clean the what? The three, and then enter what? Four, because I want to get four-sided figure. And as soon as I enter four, I will just hit on what? Enter, and then you realize that now it has changed. Have you gotten that? So we have what? Four-sided figure. So you realize that the base, okay, is a square. And what about the literal faces? Is what? A rectangle. So you realize that for the the triangle, the base was what, a triangle, but the literal faces were what, rectangle. The same applies to what, the square. The base is what, is a square, and the literal faces are what, rectangle. So you see that how many of the literal faces? So we have one literal face here, another one here, okay, yes, and another one here. So we have what, four literal faces, okay, and two identical what, bases, okay. So you see that we have our base, which is what, a square, okay. Yes, that is very interesting. Okay, let's try and see if we can get more shapes, okay. Yes, so I'm going to uh, create a six-sided figure, okay, so that we see what it is. So I will still come here, okay, I'll still come here, clear the 4 and enter 6, then I will hit my enter, and you see that we have gotten what, six-sided figure, okay. The six-sided figure here, that is very interesting, right? Yes, let's try and rotate it and see. So you see now this is the base, how many size? 6. And then the literal size, let's see. Now you see that the literal faces are also what, rectangle. So if you look at all the prisms, all the literal faces created are all what, um rectangle, okay. We can decide to click here to rotate it, okay, and it rotates very nicely like this, okay. Yes, very, very nicely like that. All right, so you see that it's very easy to do it. So GeoGebra software can help us get all these shapes. All right, yes, so that is it. All right. So now that we are able to explore our GeoGebra software, we can now use our GeoGebra software to get what, prisms from, or three-dimensional shapes from two-dimensional shapes. Then let's quickly go. Let's quickly look at few examples. Okay, let's move from GeoGebra software and look at few pictures or few examples of what, um, prisms. Then we also take few examples. We look at how we find the volume and the total surface area of those prisms. All right. Yes, that is good. All right. Great. So as I said, let's look at um, yes. So we can have our table here. You can have this shape. This is just what, a triangular prism. Yeah, so we are saying that we have two base triangular faces and three rectangular what faces. Then we also have what, rectangular prism. All the faces are rectangle. So if you take a rectangle, as for rectangle, all the faces are what, rectangle. That is, we have two base rectangle. Now when I talk about the base. Okay, the base, that is the initial shape. That is the shape where we are getting what, the pyramid, and what do you call it, the prism from. Okay, that is the base. Okay, then we can also talk about a square. We have what, two base square faces and four rectangular faces. Then we also talk about what, a pentagon, or that is what, a pentagonal what, prism. Okay, then we also have two base pentagonal faces, and we also have five uh, rectangular what faces. As for the neutral faces, they are all rectangle, irrespective of that shape. They are all going to be what, rectangle. Okay, so we can also talk about what, um trapezoidal prism, which also has what, two base trapezoidal faces, and we also have four rectangular faces. Then we talk about what, octagonal, that is where we have eight-sided figure, and then we see we have for two base octagonal faces and eight rectangular faces. So these are few examples. We have a lot. Okay, yes. So these are few of them. Now let's take our triangular prism. Okay, yes. Now we know that for triangular prism we have what, the base, the two base. Okay, which are what? Identical. They are also what? Parallel. All right. Yes. And then we also talk about the literal faces. We have one here. Okay. And then we have another one here, making what? Two. Then we have another one, making what? Three. So we have three of the rectangular faces. Now, if you take the triangular pyramid, you realize that if you take the base, okay, then we have the base length, and then if you take the literal faces too, okay, but the same base we have for the height, okay, that is a triangle. If you take a triangle, you know that for a triangle you can have the height of a triangle and the base. Okay, so our height is h. Then for the literal faces, we also have for the length, because we are saying the literal face is a rectangle. Know that for a rectangle we have what? The length. Okay, yes. Now, before that, let's we are going to find the volume of what? This shape. So what at all is volume? Now we are saying that volume is the measure of the space occupied by an object in a three-dimensional shape. It calculates how much space an object can fill a 3D shape. It is measured in cube units. So if you compare three-dimensional shape to two-dimensional shape, you remember that when we're doing two-dimensional shape, we were finding the area. It was measured in what? Square unit. Okay, because that one we picked only two sides and multiplied to get what? Our answer. But in this case, we are picking what? Three sides. Okay, three of the sides. That's why we are getting what? Cube. Okay, so when you talk of volume, we are talking about if you take a 3D container, okay, how an object can fill that space. That is what we are talking about. Okay, yes. So if that is the case, then let's try and write our formulas for volume of a triangular prism. Okay, so our volume is given as what? Half times base times height times length. Because if you take a triangle, we know that finding the area of a triangle is what? Half times base times height. And then because we have the literal faces, then we multiply by the length. Okay, yes, that is it. Good. Yes, so if we are saying the volume is that, yes, because if you take the, yes, the triangular part, that is the base, we know that we have the height. A triangle that has what? The height and the base. Finding the area is very easy. So the volume of the triangular prism is given by what? The area, okay, of the triangular face by the length of the literal faces. Okay, so we know that the literal face is a, a rectangle. Okay, yes, that is it. All right. So when we give you question to find the volume, you should be able to tell. Now let's look at the total surface area of a triangular prism. All right. Yeah. So for total surface area, you know that we have two of the phases. Okay, the base, two of the base. Okay. Yes. So you have to find the area of each of them, because we are saying that they are identical, they are the same. So if you find one, then it's the same as the other. So you can calculate for one and multiply by two. So and then so that one, if you are finding the area of that those two base, we know that finding area of a triangle where we have the height and the base, just what? Half times base times height. But because they are two, that's why we are multiplying by what? Two. Then we can also talk about the other um literal faces, because we said that we have three of them, and those literal faces are what? Rectangular faces. So you find the area of those rectangular faces, you know that area of a rectangle is what? Length times width. Okay, yes, that is length times width. So if that is the case, then we know that if this side is length, then that side is also what? Width. Then we can find what? The length times what the width as the area. Once we find one, because we are saying we have three of them, so if you find one and they are also what identical, then we can multiply by 3 as well. And that gives us what? A perfect answer. That it gives us the total surface area. All right. Yes. So if that is the case, then let's take this example and see how we can find the volume and the total surface area. So as we know that the base is 50 centimeters, the height is 25 centimeters, and the length is 30 centimeters. And we also know that the width is also 50 centimeters. Then we know that volume is giving us what? Half multiplying 15 centimeters, which is the base multiplying um, 25 centimeters, which is the height multiplying 30 centimeters, which is also what? The length. And at the end of the day, we are going to get what? 5,625 centimeters cube. So remember, I said that it is measured in what? Cube, what? Unit. So whatever you are unit that you are multiplying, at the end of the day, it should be what? In what? Cube. Okay, if it is volume, then it should be in what? Cube. If it is what? Area, then it should be in what? Square. So take note of that. But if it is should be in what? If it is what? Perimeter, then it should be what? Just what? The unit. If it is perimeter, it's just the unit. If it is area, it is in square unit. If it is volume, it is in a cube unit. So take note of that. All right. Great. Now, if we have that, then let's calculate for the total surface area. Okay, so since we know that, as we've already said it previously, then we can say the total surface area is giving us what? The area of the triangular face, which is half times 15 times what? 25. Okay, and that is going to give us what? 187.5 centimeters square, because it is area. So you remember I told you that area is measured in what? A square unit. That's why centimeters square. Now this one is just one. You have calculated for only one. Then you need to find the others. Okay, because there are two. Okay, two of the phases. So you just multiply by two and you are good to go. Very, very simple. All right. Yes. So once you multiply by two, then you are going to get your total area of the triangular face. So we have calculated for only the triangular face, which is what? 375 centimeters squared. All right. Great. Good. So that is what one the two of them gives us that. Then we also need to calculate for the area of the literal face, which is the rectangular um, part. So if you're able to calculate for one, then we multiply by 3, because we are saying that the literal faces are what? 3. Okay, so if that's the case, then you know that the total surface area, uh, so the area of the rectangular face is what? 30 centimeters times what? 15, because we are saying that we have the length as 30 and we have the width as what? 15 centimeters. So if you multiply, then we are going to get what? That's going to give us what? 450 centimeters squared. That is for one. Okay, since we have three of them, then we just multiply by 3 and then we are good to go. Okay, yeah, so multiply by 3 and then we are getting that is going to give us um, that is 1350 centimeters square. So that is for the area of the literal faces. Then we combine them. Okay, we add all of them. Okay, so if we add all of them, then what are we going to get? This is just a matter of what? Summing them up, and that is going to give you what? 1,725 centimeter square. Yes, so because it is area, we are finding total surface area. So it should be in what? Squared unit. All right, that is very interesting. All right, if that is the case, then let's look at um for, in case you are given what? A rectangle. Okay, a rectangular what? Prism. Let's look at how we are going to look at that one as well. So this is a rectangular what? Prism. All right, great. So now we know that for rectangular prism, all the faces are what? Rectangle. So If that is the case, then finding the volume is very, very easy. You know that we have for rectangular prism, we have the width, the length, and the height. Okay, so when you are asked to find that volume, you just multiply out the three dimensions and you are good to go. Okay, and in finding the total surface area, that's where most students sometimes get confused. All right, so you realize that if you are talking about the total surface area, you know that we have the top and the down. Okay, the top and the bottom what area, then you need to find what the top area and the bottom area, and you see that they are the top and the down, they are identical. So if you find one, then you get one. Okay, so the top and the bottom area, that is where we have for the length and the width. Then we also talk about what the front. Okay, the front and the back. Okay, that one also, they are also what identical. So if you find one area, then you are good to go. Okay, yes, that is very good. So front and back area, to you get what width times what the height, because you can see that we have the width and the height. So if you multiply, that is going to give you. Then we also have what the side and side what, yes, area. So that one too, you need to calculate for the side and side areas. And that one too, we can have what the length and then what the height, and they are also two. So you need to multiply. So each of them, they are two because they are all identical. So if you find one, then you get the other. All right. If that is the case, then let's take this example and see how we can. So it means that the total surface area is just what, two times what, length times width plus what, width times height plus what, length times what, height. So those that we have written is what we've written, their letters representing them. Very, very nice, very, very interesting, very, very easy. All right. Yes. So my dear students, I want you to um get this once and for all. If you have any question, if you are finding it so difficult, don't forget, you can contact me and then I will explain further. All right. Yes. So if that's the case, let's take this example and see. So let's look at this. Yes. But also remember that if you take a rectangular prism, a square prism, know that we are dealing with what, a cuboid. Yes, it's a cuboid. Yes, because as you can see, this is what a rectangular prism. This is what a cuboid. All right. So it is the same as if we ask you to find the volume of this rectangular or a square prism, is the same as asking you to find what the volume of a cuboid, okay, or the volume of what a cube. You just have to multiply the length by the width by what the breadth or the height. Okay, yes, that is how it is done. So if you look at this nice um, um, cuboid here, what do we do? Finding the volume is very, very easy. All right, so we know that for volume is just what length times what width times what height. So you just multiply these three dimensions and you are good to go. In that case, our volume is what 5,760 meters what cube. Very, very easy. Now I know you'll be able to do the total surface area, so I leave that one to you, okay, so that you do it. Try your hands, try and find the total surface area of this shape as we've done already. All right. Yeah. So this is going to be our last question. If that's the case, I want us to end here and continue next time. So in our next video, we are going to look at some application questions. Okay, real life or related application questions. How we are going to go about them. Okay. So my dear students, I want you to um, do more research. I want you to read more on these areas. Okay, so this is all about volume, total surface area of what prisms. All right. Yes, if that is the case, then we'll end here and continue next time. My name is Evans. I'm your mathematics facilitator. This is Maths TV. Don't forget to subscribe, like, and share. If that is the case, then see you next time. Bye bye.